Good morning, Eric. That was a good segue into the spotlight discussion. Let's take this 15 minutes to dig a little bit deeper. And I hopefully want to have some time for QA because there may be other TDK business groups or portfolios that may be interested. So about your journey. So you were a program manager of cell engineering at Tesla. That's all hardware, I assume. So what made you start a software company, Glimpse, that takes hardware data and betters its performance?
Yeah, so first of all, we realized at Tesla that battery quality was under-discussed bottleneck to the electrification of the transportation industry and other industries. And we were worried that if no one would address this bottleneck, this would slow down that transition. At Tesla, or at least I learned a very important thing, which is if you want to control the quality of your battery cells, you have to look inside those cells, and you have to reach a certain level of sort of resolution, because those defects can be anywhere in the cells, and they are sometimes very small. We're talking about a few microns, and they're hard to find. And battery production is done at an incredible scale. So, parts per minute, you're looking at hundreds of parts per minute. And because those defects can be or the order of a few microns, as small as a few microns, you really need a technology that can both test those cells very quickly and essentially achieve a level of resolution that was not done before. And so CT scanning, in our mind, held a lot of promise, but it was very slow. It's always been considered a lab instrument, like SEM or EDS or optical microscope. And so the mission of Glimpse is really to take this lab instrument and redesign its entire tech stack to bring it from the lab to the factory floor.
Thank you. And all of the instruments that you mentioned, they are like the workhorse of a material science company. So there should be a lot of people in the audience that kind of connect with that. And you have been very proactive in engaging with TDK business groups. You have engaged with multiple different business groups across geographies, with those with an obvious battery connection like Campace and ATL, but also with the component business groups. And you've had very good engagement with the MAG and the CABBG in Hungary, and you've had a commercial engagement with them as well. And you're also discussing with production headquarters, which is a global function. So anything they roll out is typically across the different factories in TDK. And you touched upon this just a little bit. So what is needed to take X-ray CT scanning from being a lab instrument to something that actually works in the factory floor?
So the Glimpse is mostly a software company. We do work very closely with hardware partners. The first bottleneck that we found was software. So each scan, you think of a very high resolution map of the inside of your object. Each scan is anywhere between 10 and 100 gigabytes, right? So I don't know if you've ever tried to open a 50 gigabyte file on your computer, but that's going to make your computer crash, regardless of how powerful your sort of PC is, right? So the first bottleneck to be able to consume that data is to ingest it, store it, and then serve it to your customers or to your organization. So that's why we're creating Glimpse, to essentially remove that bottleneck. And that allows you to, I will say, get out of the lab and go to, say, the pilot line or next to your factory floor, which is typically those use cases are called at-line or offline quality control. If you want to go to sort of the next stage, you need also to remove some bottlenecks on the hardware side. And so at Glimpse, we're very early on, we recognized that we would not be able to achieve our full vision long-term by ourselves. And because we did not want to start making CT scanners, there are better folks to do this out there. We started to collaborate very closely with those hardware vendors to sort of get us to the next order of magnitude of speed, right? And so yeah, essentially that's what's needed to take this technology, which is really incredible. I mean, I don't know if you ever looked at a CT scan, high resolution CT scans, especially when you're living and breathing those parts that you design, that you produce, that you control their quality. It's amazing, and so it's kind of a shame that it's bounded to the lab, and only a few people in your organization can view that data.
That actually brings me to the next question. So could you explain the difference between scan on demand versus on-premise scanning? Both have been tested, but we'd like to know a little bit more so that maybe competent business groups here are thinking of using this, they can get a better understanding. It's a good way for non-destructive testing, and so it can be very useful as a quality assurance tool. But then when you think of batteries or components, it may always not be possible to ship it across geographies. And so, yeah.
We started a company in 2023, and in 2023, the name of the game was to get to revenue as quickly as possible. And our long-term business model, the one we started a little later, which is the bulk of the revenue today, is a subscription for a deployment of our technology on the factory floor. And I'm sure most people in this room understand that those sales cycles are quite long. They take months, sometimes a couple years. Scan on demand was a way for us to go to market extremely quickly, which is we bought a scanner, we built our technology on top of the scanner, and then we offered it up to the industry. So we serve 10 people companies that want to scan battery cells. Like I said, we're starting to expand beyond battery cells, so we're scanning more and more diverse objects today. But we also serve very large companies that are sending us thousands of cells. And that's kind of the first in the industry. Never before you were able to scan hundreds of parts and be able to have a human review that, or consume that data in any way that's meaningful. So Scan on Demand is that you can send us your parts. You can send us one part, you can send us 1,000 parts. And we're extremely cost efficient because we built this sort of technology that allows us to go to be very fast, scan very quickly, and we don't have to send your data back on a hard drive. Everything is done through our web application. And then on-premise scanning is when you don't want to be shipping parts across the country or across the world to us, and you want to do the scanning on your premise. So our customers own a scanner, a CT scanner. They do the scanning. And they essentially use our technology to store that data and extract information from that data.
Could you touch upon your resolution speed? Because what is exactly needed for enabling inline scanning or on-premise scanning? At a very fast manufacturing line like TDK, I've been to Japan, I've visited some other factories, and it's a very fast line. So if you can touch upon that.
Yeah. So the answer is it depends on what you're producing. So I can talk about the battery industry. Those lines are very fast. You're producing hundreds of parts per minute in some cases. And so we're not there yet. We're significantly faster than the status quo. Recently, we announced what we call the super scanner, which is a combination of hardware and software innovations that gets you to a scan every few seconds, but you're still about an order of magnitude slower than being able to do full inline CT scanning at the full cell level. But what was needed to get there is really look from first principles at every single bottleneck that prevents you from going fast today and removing those bottlenecks one after the others. Some are hardware, some are software. I think the additional complexity in the battery industry is that you need to reach a very high level of resolution, right? So when you think about throughput and scan time, you always have to talk about what is the image quality that I need to achieve. And so talking about one without the other doesn't make a lot of sense. So that really is the challenge is I want to scan very quickly, I want to scan my entire part, and I want to reach micron-level resolution.
Thank you. One of the goals of Glimpse is to minimize the time for insight, right? And provide actionable data, whether it's batteries or its components. Could you provide an overview of the Glimpse box, which is the high-performance computer, and the Glimpse portal, which is the web app? And it'll also be nice if you can touch upon whether TDK teams, if they already have a CT scanner with them, whether they are able to work with you.
Right. So you mentioned time to insight. This is a very important metric for us. It's kind of our North Star, right? Because it's one thing to have a high throughput QC technology, but if it takes you hours to interpret the data that comes out of it, it kind of defeats the purpose. And so time to insight, reducing scanning time is one component of reducing time to insight, but it's not the only one, right? So leveraging computer vision to automatically extract those features, making those dashboards consumable by anyone in your organization, and being able essentially to draw a conclusion about what's going on in your factory, could be a battery factory or a factory producing other parts, in seconds. That really is a superpower. And it's the difference between flying blind and having a really tight control over your processes and the quality of your product that you output. The way we enable this is we have a Glimpse box. We call that a Glimpse box. It's a high-performance computer. It's pretty small, fits under your desk. It's powered with some of the latest, compute technologies, we hook it up to the CT scanner. We can deploy on any available CT scanner. Doing so, we significantly improve their throughput, and we have to do a lot of edge processing, right? Because you cannot send 50 gigabyte files every few seconds to a cloud web application. So we do a lot of edge processing. That's the Glimpse box. The Glimpse box takes raw data as an input. You're looking at hundreds of gigabytes or terabytes per minute, and then outputs a highly compressed, lightweight version of those scans, and then with those features extracted. So you can turn any CT scanner into a quality monitoring dashboard. So that's the Glimpse box. The quality monitoring dashboard, that's what we call the Glimpse portal. I had a screenshot of the Glimpse portal on this slide. I would love to give you guys a demo after this presentation. And that's where you can consume this data, and it really is a system of record for your product quality. So especially in battery, it's very important because you're producing batteries. Those are going to be shipped to a pack maker or a car maker. They're going to be assembled into a pack. Then the cars are going to wait on the parking lot for a couple of weeks. They're going to be driven for a few weeks, a few months, a few years. And at some point, they might fail because of defective cell. If you don't have that system of record and you have one failure, you have no idea of figuring out if your failure is isolated because there might be one random cell that carried that defect, or if it's your full fleet that has this problem. And so how do you react, right? So you need that system of record. And so you can think of capturing a digital fingerprint of your build quality over time and storing it for years in case you have, God forbid, problem in the field. So that's the Glimpse portal. It's a very snappy application. It takes a few seconds to get to any scan, takes a few seconds to draw any conclusion from your quality. And we're very excited to bring it to other industries as well, because we have seen the excitement from customers across other high-value manufacturing industries, including capacitors, for the use of this technology.
So 2 points you made. A very important one is that you are already familiar with the battery industry with your long association with Tesla, but you're trying to move into newer areas, such as components, which is very useful to TDK. And the other thing is being able to catch a problem before it occurs after it's deployed. That's also very important to TDK. So that brings me to the next question. What value do you unlock for your customers by introducing this new stream of CT scanning data into factory environments? Especially in the case of Capacitance BG Hungary, you worked closely with Martin, and there were at least like 50 emails back and forth to optimize the things that are required that will make sense for them. Right. Could you provide more details on how you guys are working on proving the business case for your technology there?
Right. So, I visited Martin and his colleagues in Hungary. It was my first time in Hungary. It was quite a fun experience. And Martin essentially had the idea of leveraging this data, inside maps of parts, in this case capacitors, to predict failures that would otherwise be found through a very expensive and long process in their factory. So I think it's one of the last steps of the process where they're testing the parts in such a way that takes, I think, days or weeks, right?
It's months, actually.
Month, right. So it's kind of a big bottleneck in their factory. And so because we're introducing this new stream of data, right, which is CT scans, if you do it fast enough and you extract the right features, you might be able to achieve the same goal, which is weeding out the bad parts before they go out to your customers, without having to wait for months before the parts fail naturally in your process. So that's kind of the idea. And I think just building up on that, high-resolution 3D map of parts was not something you can consume and access at scale before. And so because we're changing this, we're essentially bringing ideas to those factories where instead of having a very lengthy process or a destructive process where you're cutting your part in half and you're trying to find those defects, right, which is by definition sampling based and destructive, you can remove or circumvent some of those lengthy and expensive processes with simply non-destructively testing at scale.
Thank you. We now shift gears from the actual mechanical process to data storage. So data storage in-house, locally at the user location versus upload to cloud. A lot of manufacturing data for TDK as well as for any manufacturing facility would be very proprietary and confidential. So your thoughts on this?
Yeah, so I have strong thoughts on this. So we provide both options, right? We provide the option where the data can be stored on a cloud-based application, and I'll share a little more about how we do this. But we also provide the option where the data is stored on-premise and it's air-gapped, and only people connected to your internal network in your factory can access that data. The second option is much more expensive, and when we generally have those discussions, people very often go for the first option because it's much less expensive for us to maintain. I will say when we store your data in cloud, it's a single tenant, so it's very secure. We have built best-in-class security practices from the ground up, from day one. The battery industry is very, a lot of confidential information, so our customers want to make sure that their data is stored and safe. It's segregated from other customer data, and this is generally a discussion with the IT team. I think we have found that more companies than what people might think are comfortable with cloud technologies if they're secure, and oftentimes more secure than on-premise solution. But again, we offer the possibility of storing your data on-premise if that's needed, but because we have to maintain this technology, you can imagine that if we don't have external access to it, it's much more expensive for us to maintain its performance over time.
So if there are TDK teams in here that are listening to you and would like to collaborate or evaluate this methodology, could you explain a little bit about your business model?
Right.
You charge one time, or is it a pay-as-you-go service?
Right. So the scan on demand is you pay as you go. We're extremely cost efficient, and so it really is a way to welcome customers to try our technology, get a feel for it. You can send us one part, you can send us 100 parts. It really is up to you. There's no subscription. For the on-premise scanning, where we deploy our software on your premises, there is a fixed cost. We call that a deployment fee, right? So we come with the Glimpse box, this computer, we hook it up to your scanner, we optimize the scanning recipe, we plug the Glimpse box on your network, we add users to the portal and so on. And then there's a subscription fee, and the subscription fee essentially makes sure that the performance of the Glimpse box and the Glimpse portals are maintained. By performance, I mean both availability, uptime, but also the computer vision algorithms, right? So when you scan parts per minute or parts per second, you don't want to have to manually review the data, so we use computer vision to extract those features. And computer vision algorithms sometimes they feel magic, and sometimes they're very painful because they fail. And so the subscription is to enable us to allocate enough resources to make sure our customers are happy with the performance of our computer vision algorithms. So that's the subscription, yearly subscription part of the on-premise scanning business model.
Thank you, Eric. This has been a wonderful discussion. I think we need to take a few questions for this session for sure.
Could you also go back in time and identify together with the factory management what caused the problem? Is that something that you're considering? Thank you.
Yes, a big enabler for that. So the question was, can we go back in time and figure out when the problem started, where it started, what might be the source of it? Yeah. Because we're building the system of record where you're scanning with us for months, years, and we're storing the data indefinitely, and we're making this very efficient, cost efficient, we can retroactively deploy new computer vision algorithms, right? So imagine you run your factory for 5 years, and 4.5 years in, you identify a new problem, right? Maybe it's customer feedback from the field. Maybe it's production associates that has identified something that they were not looking at before. The beauty of our technology is you can ask us to develop and deploy a new computer vision algorithms pretty quickly. We are constantly working on reducing the time it takes to develop those algorithms. And then we can retroactively deploy it for 4.5 years. And so doing so, you can very accurately figure out when the problem started. Obviously, it's a problem that needs to show up in a scan, right? It needs to be a geometrical variation in your part. And then you can also run correlation across lines, across shifts, right? Across time of the week, if it's a weekend, if it's during the weekdays, and be able to identify when the problem started, if it's a consistent, recurring, or if it happens every other week or every other month. But then obviously taking this information and then going to your factory and fixing your factory, that's kind of the role of the customer, because we're missing a lot of context information. We're also working on integrating more data sources onto the portal. So in the case of batteries, you're thinking about voltage data, resistance data, and once you combine those two data streams, geometrical data on one end that we provide, and electrochemical data on the other end that other tools in the factory provide, then you can really have very powerful synergistic sort of prediction mechanism.
Yeah, I think this is one area where you probably have to work closely with the TDK teams who have the internal knowledge on what processes are happening that showing up as pictures that you identify.
That's right.
Yeah. We can have a couple of more questions.
Hello, I'm Hugh Dong. I'm from AM Batteries, another ex-Tesla guy. Eric and I used to work together. So congratulations, Eric. Great progress. So currently you're interrogating the cell at the finished good level, right? I could imagine there are opportunity to capture the value in the front end where you're interrogating the jelly roll so that you don't have to incur costs, right? Process costs associated, and then get a defect at the back end, right? I could imagine that's super valuable for cell manufacturer, right? Could you comment on something, if you're looking to do that, or is that an opportunity for you guys?
Yeah, so some of our customers actually scan the drill before pre-assembly, right? Pre-electrolyte filling, pre-assembly. It's interestingly, you get more insight of your scans once the drill has been inserted into the can, because that's where a lot of damage happens, right? Once the electrolyte has been filled in, because you have a lot of swell, so there's also some potential problems that happen. And so you get a better bang for your buck in terms of dollar per image created or dollar per scan post-assembly. But yeah, some customers scan jet rolls. You have to be careful because those are a little harder to handle, right? You could deform them. But yeah, that's entirely possible. CT scanners, they're not cheap, right? They're expensive technology, and with our hardware partners, we're trying to not necessarily reduce the capex cost, but reduce the dollar per scan, right? Which is part is capex, but also throughput. But because they're not cheap, you want to make sure that you insert them in your factory at the most strategic place that you can to maximize their value. And generally speaking, we found that it's either right before formation for the battery nerds in the room, or after formation once the inside of your cell has sort of mechanically swollen and potentially degraded if you have a defect.
Maybe we can have one last question. Anyone in the components TDK business groups that would like to?
Hi, Omar Abed. I'm the CTO for TDK and Ventures. We make MEMS sensors. I'm curious, you talked about high resolution. What kind of resolution can you achieve? And also what size of defect, minimum defect, can you detect? I'm thinking about on the semiconductor side and sensor side, is that a tool that we could deploy? As we talked about months of reliability testing, could it be anticipated through early imaging? So I'm just curious.
Yeah. So at a high level, we're hardware agnostic, but that said, there are things you can do better and faster with certain types of hardware, and really the hardware is going to drive your resolution. We talk about voxel size, right, which is the size of it's a pixel in 3 dimension, and that really drives your resolution. Typically, we're in the 5 microns to 50 micron range. That really is where our sweet spot is. So if you're looking to image transistors, that might not work. But for packaging and macro defects, we're very relevant, and we're starting to do more and more work on the consumer electronics parts to sort of get those defects. So I guess it depends what length scale and what types of defects you're trying to image. But for anything sub 1 micron, you're probably more in the SCM world.
So you said 5 to 15 microns?
50.
50 microns. But how dependent is that on the actual instrument being used?
Somewhat dependent on the components in your scanner.
Not the component, so the CT scanner's resolution, because you can work with third parties, you can work across the spectrum. So how dependent is it on that?
Right, and so when I mean component, I mean the X-ray source and the detector in your scanner. Also, it's very dependent on the size of the part, right? The bigger the part, the worse the image resolution in general. So we found a lot of success in small pouch cells, in cylindrical cells, in medium-size prismatic cells, and then found a lot of success in medical implants, small wearables, and so on. So if I just, to give you a range, typically this size, right? So maybe bigger than a fist, between a fist and a human head, that's kind of the sweet spot for us. Smaller is better, but obviously if the object is really, really tiny, it becomes a little hard to handle, put inside the scanner and unload as well.
Thank you so much, Eric. Appreciate all the questions as well, and you will be at the demo downstairs. Thank you.